Right. The following Zoom session is being recorded and will appear later to, oh, wait, didn't click it enough. Here we go. The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are 3 different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmail@ybcc.edu and I will respond as soon as I can. So, good morning, Math 93 students. Today, we will be covering section 9.1. We're going to spend 2 days on this, so we'll cover the first part today. I haven't corrected your chapter 8 tests yet. I'll be doing that today and on into this weekend. So anyway, if you are wondering about that, I will get it done as soon as I can to give you your final test grades. All right, so with that, we're going to go into section 9.1, and we're going to deal with radical expressions and radical functions. Radicals, square roots, cube roots, fourth roots, that kind of thing. So let's start off with me getting my papers out of the way there. And then, what does it mean if I asked you about your roots? What am I asking you about? Am I talking about your hair?
Maybe.
Maybe, but more likely. So I said, Anthony, so tell me about your roots. What am I asking about?
I would say where my heritage, my culture,
your heritage, your culture, where you began. Okay? So your roots is like going back to where you started. Okay? So let's say we take 3 and we square it. So now 9 is a square, right? It's 3 squared. We want to know its roots. Where did this square come from? Oh, it came from 3. So the square's root is to go back to the number that we squared to get to 9 in the first place. I don't know if that makes any sense or not. In fact, you could also call it the unsquare. If I had invented this, maybe instead of calling it the square root, I would have called it the unsquare. In fact, we could also say that 3 squared, take the square root, gets us back to 3. So a square root undoes a square, just like addition undoes subtraction, division undoes multiplication, roots undo powers or exponents. All right. Now, it's true that the square root of 9 is 3 because 3 squared equals 9. However, -3, the quantity squared, also equals 9. So then why don't we say the square root of 9 equals -3? We don't do that. When we take a square root of a specific number, we only get what is called the principal square root. That is to say, the positive root. And if on your calculator, you say, okay, calculator, give me the square root of 9, you're only going to get the 3. All right. Any questions so far?
Yeah, is that kind of like absolute value?
Well, you know, what's that, Cindy?
So can a square root never be negative?
That is true. And let's go back to Anthony for a minute. And I'll get back to you. So it's funny that you bring up the whole idea of absolute value, because where I'm going to go here pretty quickly is going to involve absolute value. So I'm going to put you on hold for just a minute, Anthony. And then Sydney, you said, so is it true that a square root can never be negative? Is that what you said?
Yeah.
And yes, that is true. A square root can never be negative. Now,
I'll put that in notes.
What?
Said I'm gonna put that in my notes real quick.
Now, you could have negative the square root of 9, which would be -3, but the square root of 9 is just the 3, and the square root symbol is a grouping symbol. So this is like taking -1 times that. So even though my final answer is -3, the answer from the square root part is just positive. Now, it could be
So,
0.
yeah.
The square root of 0 is 0, but yeah, the square root of a number can't be negative. In fact, let's say an even root of a number can't be negative. And we'll come back to that in a minute. I kind of want to build to that idea, but let's see, what did I want to do? Oh, yes. Okay. So the square root of 9 is 3. Let's take a bigger look at that. This number inside is called the radicand. These are some strange words coming at you. So the quantity inside of this thing here is called the radicand. All right. This thing here is called the radical. So the radicand is inside the radical. And no, I didn't stay up late last night trying to come up with weird names for it. That's just what they are. Now, I want to jump ahead for a minute and then we'll come back. If I have this, oops, let's try that again. This says I want the cube root of 8. This is the radicand. This is the radical. This number here is called the index. The index tells you what root you are taking. So if I have the cube root of 8, that means I'm uncubing 8. So in other words, what answer times itself equals 8? What times itself is 8? That's a question for you. So what is it?
2.
2. Good. So the cube root of 8 is 2 because 2 cubed equals 8. So this says I'm going to uncube it. I'm going to take the cube root. Now, mathematicians are efficient, and if something is done over and over and over, they tend to have a shortcut notation. So for instance, x is equal to 1 times x to the 1 power all over 1. But all those ones, we don't typically write them there. We just know that they're there, but we don't want to bother with it. It's just implied there, okay? Now, technically, I'm taking the square or second root of 9. But because the square root is the most common root that we use, when we want to take a square root, we don't write a 2 for the index. So if there's no index, we're talking square root. So this is the square root, this is the cube root, this is the fourth root, this is the fifth root, etc., etc. But I don't need to put a 2 there if it should be a 2, I can leave it off because it's implied. Does that make sense?
Yeah.
Is it only when it's 2?
Yes. Yes.
Okay.
And it isn't wrong to put the 2 there, but typically we won't. It's just sort of understood that, oh, if there's no index, it's a 2.
It's a 2. It's an implied 2. How about a -2?
We can't have a negative index.
Okay.
And we'll deal with that later on in this chapter.
Later.
Sure.
Okay.
Sure. I can make all kinds of promises, later, right? Okay. Now, what's the square root of 4?
2.
2. What's negative the square root of 4?
-2.
What's the square root of -4?
There is
2.
none.
There is no real number. So I'm going to say no real number. Okay. There is an imaginary number, but we're not going to go there right now. But suffice it to say you can't take an even root, as in this case, we're talking square root or fourth or sixth. You can't take an even root of a negative number and get a real number answer. Okay. Now, let me back up a little bit. Earlier I said, when you take a square root, or in general, when you take an even root of a number, you can't get a negative answer. Now I'm saying you can't take an even root of a negative number. So if I've got this, and I'm going to say n is my index, if n is even, okay, so it's 2, 4, 6, 8, 10, 12, whatever, I can't have a negative number inside, and I can't have a negative answer. Okay, so if you take an even root, you can't get a negative answer. If you take an even root, you can't take, or I should say, you can't take an even root of a negative number. So the radicand can't be negative. Now, I know it seems like I'm going on and on and on about that. That's because I've just given you two of the three most important ideas in this whole chapter. Okay. One, when you take an even root, you can't get a negative answer. Two, you can't take an even root of a negative number. All right. Now, we did this a minute ago. What's the cube root of 8?
2.
2. All right. What's the cube root of -8?
There's no real number, right?
Ah, careful. I said you can't.
-2.
What?
-2.
Yeah, but back to Roger for a second, then we'll get to you. Good old SB there. What I said was you can't take an even root of a negative number. 3 is odd because look, and then as you said, SB, -2, the quantity cubed gives you -8. So you can take an odd root of a negative number. And you can get a negative answer when you're taking an odd root. So the restrictions have to do with even roots. Odd roots, yeah, odd roots, no restrictions. It's the even roots that we got to watch out for.
Okay, I thought you just meant that there can never be a negative radicand. Since 8 is the radicand?
There can't be if the index is even.
Okay.
All right. So if it's a square root, fourth root, sixth root, that kind of thing. So,
Okay.
so like the fourth root of -16 is not real. Okay. And the fourth root of something can't be a negative answer. Okay. Because we're talking even roots. But with odd roots, you can. Okay. Now, what is the square root of 3 squared?
3.
3. Good. And I'm proud of you for what you didn't do. What you didn't do is say, well, let's see, 3 squared is 9 and the square root of 9 is 3. That's correct, but you shortcutted it, went straight for the jugular vein or whatever. The index and the exponent undid each other. You follow what I'm saying? The implied 2 is the index. Here, let's put it in there in red. Okay.
That made sense.
Good, good. All right, now, careful. What's the square root of -3, the quantity, squared?
That would be no real
Let
No
me
real
give you a
number?
clue. Let me give you a clue. Order of operations.
Okay. But isn't
What- 9?
the
What,
Sorry.
Sydney?
Would it be 9?
The answer?
Yeah.
No, you're getting warmer though. Anthony, what were you saying?
Oh, well, I was going to say the index is even, so it can't have a negative.
Okay, let's go back to what Sydney said. The answer isn't 9, but if we followed order of operations, we would do what's inside the grouping symbol first, right?
Ah, the negative cancels itself out, so it ends up 9 anyway. Okay, I see. Okay, tricky.
Yeah. Yeah. Okay.
I see.
What's that?
I see. So you have to make it 9 and then square it.
Unsquare it. Yeah.
Yeah, unsquare
Yeah.
it.
Yeah. Because if we just cancel the index and the 2 exponent, we'd get -3. And remember, you can't get a negative answer when you take an even root.
Right.
All right. Okay. Now we're going to wander out into the deep end. Hopefully you've got your life jackets with you. We're going to say that x is greater than or equal to 0. All right. So x is not negative. I am telling you that up front. X is not negative. So what's the square root of x squared?
X.
Right. And that's true. We are told that x is positive or 0. So we didn't get a negative answer. So we're safe. Okay. Now, new set of conditions. X is any real number. Now, what's the answer?
There is none. It's not real numbers.
There is. Keep in
Isn't it
mind.
still X?
Well, but what if x is -3? Then we'd be getting a negative answer. What could you do to assure us that that answer is not negative?
Isn't it plus or minus X?
No. I know where you're going with this. That's later. What can I do to make sure that x, the answer, is not negative? Absolute value.
That makes sense.
Good, because sometimes it gives people a headache. So the square root of x squared under these conditions would be the absolute value of x. That way, if x is positive, we're safe. If x is negative, we're still safe because we're taking the absolute value of it. So that makes it a positive number or 0. It tells us it will not be a negative answer, so we don't break the rules. Okay.
So could you get a negative number and then put the absolute value over it, making it correct?
Okay, that's a good question. Let's look at, let me see here. Let's do this. Let's take this. Oops, I didn't get rid of something there. I wanted to, this little piece here. And in fact, let's do this. Like that. But
Yes.
since we know the absolute value of -3 is 3, we could keep going. Whereas here, we don't know specifically what x is, so we have to stop there. But yeah, if I'm understanding what you were asking.
That's that answered my question perfectly. Thank you.
Good. I'll be able to sleep well tonight, knowing that at least one question today I answered correctly. I'm sorry, am I having too good of a time? Yes.
It's
All right.
Friday.
Oh, sure. Right. Okay. Let's take a look at some other things here. In fact, let me rewrite this. So, and here we're saying x is any real number. Okay. So now what about the cube root of x cubed? Again, these conditions for all these problems we're going to look at. What's the cube root of x cubed?
X.
Just x?
I think.
Why?
Absolute value.
Oh,
isn't
because
it?
any real numbers. You're right. Absolute value X.
You were right in the first place, Anthony. And I don't know if it was Sydney or who talked you out of it. This is correct. We're taking we're taking an odd root. We're taking the cube root. So the answer can be negative. So
Negative.
putting the absolute value bars there would be wrong.
Ah, man, this is tricky.
Okay, I know. I'm that evil laugh. I need to practice that more. All right. What's the fourth root of x to the fourth?
That one would be absolute value X
Good.
because it's even.
Okay. This is Mean Friday. I'm being mean. My idea is to trick you. Just when you think you've got it figured out, throw you a curve.
X 2, X to the second power.
Okay. Do I need absolute value bars?
Since it's even, you have to have the absolute value.
Nope.
Since it's an implied 2 on the input or on the, what's it called? The index?
Index. Nope. I don't need absolute value bars. Can anybody tell me why?
Huh.
Okay. Consider our answer. Let's say x is negative. What's a negative times a negative?
Positive.
Let's say x is 0. What's 0 times 0?
0.
Good. Let's say x is positive. What's positive times positive?
Positive.
So no matter what x is, because the answer is squared, it's not going to be a negative number. X itself might be negative, but x squared wouldn't be negative. So we don't need absolute value bars there.
Because it always cancels itself out.
What do you mean? It cancels itself
When
out?
you 2 times a negative by a negative, it,
Yes.
it becomes positive.
Sure. Yes. Yes.
Okay.
Okay. So
Okay.
So there, we don't need absolute value bars. Okay. Be careful with it. Think it through. Don't just try and come up with some rule. I think it's more complicated to remember the rules than it is to just kind of deal with each situation. Okay. All right, hang on here. Let's see here. Already talked about that. Already talked about that. Okay. Yes. Yep. Want to make sure I covered all the details ahead of time. Yes, I did. So now we're going to look at some examples. This says evaluate each square root without using a calculator. Some of these problems we're going to do without a calculator. Others we're going to use a calculator. So if you have your calculator with you, great, get it out. We're going to use it. If you don't, recall way back at the beginning of the course, I told you that you could go online and in a Google search, put in factorial calculator, and it would bring one up that has factorials. That same calculator also has roots and all of that stuff. So if you don't have the TI-30 X Roman numeral 2S, that thing, there's a place online you could get one. Okay, anyway, now, so what's the square root of 100? Well, what squared is 100?
10.
10.
So the square root of 100 is 10. All right. What's negative the square root of 64? Well, what's the square root of 64?
8.
But then this negative sign on the outside comes and hits it. So again, I didn't get a negative answer for the square root. I got 8, but then that negative sign out front got moved over and applied to the 8 to make it a final answer of -8. Okay. How about this one? The square root of 4/25. Often math books create a problem in that they introduce problems without thoroughly covering the ideas behind it. And this is a perfect example because I'm going to kind of go through and sort of get you to buy what I'm saying by faith. And then later on, I'll explain the rule as to why we can do that. And I know that's kind of
Isn't it? Is
Go
it
ahead.
2/5?
Yes, it is. But what I'm going to do to get there is I'm going to tell you if I have a fraction inside of a radical, like I do, I can separate it as the square root of the numerator over the square root of the denominator and do it in pieces. Now, you can go straight to the answer if you
Okay.
see it, but you can
Okay.
also split it up this way. But I'm not going to
Okay.
fully explain why until later. Okay,
Okay, thank you.
you bet. We'll get there though. Now, when you take a whole number and you square it, the answer gets bigger, right?
Yes.
In fact, if you take a number larger than 1 and you square it, the answer gets bigger. So 7 squared is 49. Likewise, if you take the square root of a number larger than 1, doesn't the answer get smaller? If I take the square root of 49, I get 7, right?
Yeah.
That sounds right. Yeah.
Okay, but what if you multiply a number smaller than 1 by itself? Isn't 4/9 smaller than 2/5? Well, maybe it is, maybe it isn't. You're not sure. Let's see. I'm gonna cheaply go through and say, well, 2/5, this is 0.4, and 4/9 is 0.444 repeating. So this is, oh, this is larger, isn't it? So I guess what I said isn't true. Well, forget that then. Consider this though. What was the answer?
2/5. Yep.
All right. Which of these is larger? 4/25 or 2/5? I'm not sure what happened in that last one. I think I had a brain fade or something, but we'll just forget it ever happened.
2/5 is larger, isn't it?
2/5 is what?
Larger.
So we took a square root, but the answer got bigger. Doesn't that seem kind of weird?
Is that because it's a fraction?
Yes.
Okay.
The whole thing I'm trying to get at here is that because
And
so
a fraction is kind of a way of saying division anyways, isn't it? So, I mean, you're kind of multiplying division. You're working backwards here because you've got your fraction and then it's being divided again by the square root. So it kind of like multiplication, isn't it?
I'm going to leave that. I'm going to leave that hanging. I'm not.
That's complicated. It's getting complicated. That's all I know.
That's okay. 0.16. What's the square root of 0.16?
Point.
0.14. No, 0.04. No.
Would it be point? Is 0.04 or? Oh yeah, 0.04.
So I'm hearing people say that. Okay, let's check our work. If that's true, what's this?
It's 0.4.
Ah, it's 0.4, right? Oh, look, isn't that bigger than the original? Isn't 0.4 larger than 0.16?
Yes.
Yes.
So we took a square root and got an answer that was bigger.
This
'Cause
is
you're a wizard.
confusing.
No, I'm not a wizard. It's because it's a fraction.
Because you're a wizard.
Ah, because it's less than 1. Anyway, I just mostly wanted to mess with your heads a little bit this morning to say, be careful with this stuff. Okay, be careful with it. It won't kill you, but just be careful with it. All right, now, calculator. Square root of 340. On your calculator, and again, I don't know what you're using, but typically there is a button that it's either, on my calculator, there's an x squared, and then the second function key is a square root, okay? Don't confuse that with something that looks like this. This is like the xth root. This we want for the square root. So to find the square root of 340 on my calculator, I'm going to go second and then square root. So having done that, second square root, this shows up. A square root with a parenthesis. I'm going to type in 340. I'm going to close the parentheses and I'm going to push equals. And I'm going to get 18.43. Let's see, it says 4 decimal places. So 439088891, but that would be the 4th decimal place. So how do you round? You go one more place to the right, the 8 rounds up. So I'd have 18.4391. That would be my answer, approximate answer to 4 decimal places of the square root of 340. All right with that?
Yes.
If you have a calculator with you, try it. If you don't get the right answer, let me know. If you don't have one with you, for this chapter, I would say plan on having access to a calculator because we'll be using it a bit more than we have in the past. Okay, now, let's see, how are we doing? The square root of 64, the square root of 64 t squared. The instructions say this: simplify each expression, okay? Assume that all variables are unrestricted. Now, that's their way of saying it can be any real number. It isn't necessarily negative, it isn't necessarily positive, it isn't necessarily 0. It can be any of those. So earlier I said, you know, x can equal any real number, okay? Now they're saying unrestricted. So t is unrestricted. Let's see here, restricted, can't spell with an R. So they're saying it can be any real number, all right? So what would the square root of 64 t squared equal?
8t?
And that's it?
That might get an absolute value because hold on, the index is even, and so if t is unrestricted, then this could be positive or negative, which would make it incorrect. There you go. Yeah. Like
Yes, good job, Anthony. There's your correct answer. So this requires an absolute value symbol around the t.
that. Hoy.
Okay. Of course, now that you got that one right, my goal is to try and trick you, see?
No.
I'm so mean. Isn't this Mean Friday? All right. The square root of 36 y to the 4th.
Again, we're going to assume that y is unrestricted.
Yep. Yes.
Okay.
So this is all the variables in these problems are unrestricted. Yes.
So 6y squared with the absolute value on the y squared?
Nope.
Or no?
No. Why
So
don't
just
I
that?
need it? What? Why
Is
don't
that the answer then?
that's the answer. Why don't I need absolute value bars around the y squared? Because
if the y is squared, or whatever happens to be the case is squared, then even if it's a negative, it'll make itself a positive.
Bingo. This is going back to the stuff we looked at earlier. Let's see, where was it here? And then, oh, here. So it's like this scenario right there. Because our answer, a variable is squared, it's not going to end up being negative.
So just for the sake of example, if your y value was to the 6th power, making your answer y to the 3rd power, wouldn't then it would have to get absolute value put around it?
Okay,
Because if it was to the 3rd power.
that's a good question. Let's look at that. So this,
Exactly.
so 6y cubed. So then the
And then
question
that
is,
cubed would have to be absolute value, because if it's unrestricted, then it could end up as a negative, making it incorrect. So then it would have to be, yeah, like that.
you're getting it. Good job. You're getting it. In fact, that was basically like the next one I was going to do, but you're thinking ahead. That's
Oops.
good. No. I'm not that complicated to figure out. Okay. All right. Now let's see here. Oh, let's do this one. Again, all variables are unrestricted.
So 2n to the 4th with absolute value around it. Around the n, around the n.
There's
no,
no
because to the
absolute
4th.
value.
Right, because it would make itself, the negative would cancel. You're right. No absolute value.
There you go. Okay. Like I say, take it slow. Be careful with it. All right. Now, let's see here. This says complete each table and then graph the function. Okay. What I'm going to do, I'm going to switch to our other screen so that I can do some graphing. So hopefully this will work. Sometimes it gives me issues. All right. So can everybody see my graphing screen?
Yes.
Great.
Yes.
Okay. It says f of x equals the square root of x plus 2. And it gives us a table. And it gives us some x values. Okay. Now, order of operations, you would put x inside the square root, take the square root, and then after that, add 2. In other words, the plus 2 is not inside the radical. All right. So f of 0 would be the square root of 0 plus 2. What is the square root of 0?
0.
Right.
0.
And 0 plus 2 is
2.
2. I know I've got you so nervous about answering because of all the questions or tricky questions earlier. I'm not trying to mess with your minds now. Okay, for a change. F of 1 is the square root of 1 plus 2. What's the square root of 1?
1.
1 plus 2 is?
3.
Okay. F of 4 is the square root of 4 plus 2, which is, what's the square root of 4?
2.
And 2 plus 2 is?
8. No, 4.
4. F of 9 is the square root of 9 plus 2, which is, what's the square root of 9?
3.
And 3 plus 2 is?
5.
5. And f of 16 is the square root of 16 plus 2, which is, what's the square root of 16?
Oh man, this one is 4.
And 4 plus 2 is?
6.
6. Okay, let's see. 0 2 is right there. 1, 3 is right there. 4, 4. Let's see, this is 5, and we'll extend this out a little ways here. Let me move the pictures of all of us people here. Get that out of the way. This is what, 10. This is 5, and this is -5. Let's see, where were we at? F of 4 is 4. F of 9, so 9 is here. 9, 5 is right there. 16 is off the graph. But so my picture, my graph, is going to look like that. Okay.
It's not a function.
Oh, but it is too. It is a function. Let me.
Doesn't it have more than one x value? This makes it not a function.
If it had, first of all, because they use that, they either lied to us, which they won't, or it's a function. But if I take vertical lines and pass through this, do I ever cut through the graph more than once?
Ah, okay.
Like, let's say that
Backwards.
it also had this piece. Then you'd be in trouble.
Okay.
All right. So
Then it would repeat.
yeah.
I get it.
Oops.
Sorry about that.
No, not at all. That's the whole point here. You're supposed to ask, figure out what's going on here. All right. Notice the values of X that they chose. Why don't you think they just use 0, 1, 2, 3, 4, 5? Why did they skip around like this? What's special about those X values?
They all make for really good roots.
Yeah,
Square roots.
they're all
Are they,
perfect. Go ahead. What?
are they cubed?
They're not cubed, they're squares.
Where? Okay.
The square root of 0 is 0. The square root of 1 is 1. The square root of 4 is 2. The square root of 9 is 3. The square root of 16 is 4. So by choosing inputs that we're going to go in a square root, by choosing squares, the square root of a square is a nice number. So and a nice number plus 2 is still a nice number. Okay. Now, had they done something like this, 0, 1, 2, 3, 4, etc., we could still come up with values, but they wouldn't be as nice, and we'd probably have to use our calculator. Like, I don't know what the square root of 3 is. It's 1.7 something. We'd have to round it off.
320508808.
Something like that. Yeah. But my point is, we could still graph it, but it wouldn't be as easy. So by planning ahead, by choosing nice values, we get nice results. Okay, does that make sense?
Yes.
All right. Let's see here. I want to go to the next page. And this says, okay, yeah, all right. I know what I'm doing. Sorry. And there, and we're going to put in our lines again. All right, it says graph each function, give the domain and range. F of X equals the square root of X plus 4. Now, here, the plus 4 is inside the radical, not like earlier with the plus 2 that was outside. Okay, let's try and make this a little nicer. But again, I could put in, any value of X I wanted, but I might get some numbers that just aren't that nice. So what would be nice is if my numbers were perfect squares. Okay. for instance, let's see here. 0, 1, 4, 9, 16. Those are all perfect squares, aren't they?
Right.
But if I put those numbers in here, I'm not going to be taking the square root of those numbers. I'm going to take that number plus 4 and then take its square root, aren't I? You see what I'm saying? In other words,
Yes.
what's that?
I was
Yeah,
just,
but it's,
yeah.
yeah.
Okay, so in the previous problem, in fact, let's go back there. Let's see here. This, just X was inside. So picking X's that were perfect squares worked out nicely. But here, we want that whole thing to be a perfect square, all right? So basically, I want this to be X plus 4. Now, as soon as I put an X value in, 4 is going to get added to it. Then we're going to take its square root. So if X plus 4 consists of those values, how would I pick my X values over here?
By taking 4 from each of those?
Bingo. What's 0 minus 4?
Minus 4.
What's 1 minus 4?
Minus 3.
What's 4 minus 4?
0.
What's 9 minus 4?
5.
What's 16 minus 4?
12.
Yeah, now those numbers in and of themselves don't look that nice. But again, we're finding f of negative 4 is the square root of negative 4 plus 4, which is the square root of 0, which is 0. F of negative 3 is the square root of negative 3 plus 4, which is the square root of 1, which is 1. F of 0 is the square root of 0 plus 4, which is the square root of 4, which is 2. You see what's happening there? Now, did I have to do it this way? No, sure, I could have picked any values of X, 1, 2, 3, 4, and 5. But I'm trying to do it, I'm trying to plan ahead so that I get nice, easy points to plot. So by doing work ahead of time, my graphing becomes easier as opposed to just picking numbers and sticking them in there and then having to deal with, well, where is 1.73 on the graph kind of thing? All right. And let's see, f of 5 would be square root of 5 plus 4, which is the square root of 9, which is 3. And I'll just bet you that's going to be 4. So now I've got negative 4, 0 and negative 3, 1 and 0, 2 and 5, 3 and 12 are off the graph. So we've got this graph that looks like that. Okay. Harder work here, nice graph over here. Now, question. What's the domain of this function?
Anything greater than or equal to, was it negative 1, 2, negative 4, and then up to infinity?
Correct. What's the range?
Anything greater to or equal than 0 to infinity?
Correct. Now, let's go back. Let's see here. How are we doing? Yes. Let's go back to here. And notice I put in negative 4. But I'm not taking the square root of negative 4, am I? I'm taking the square root of negative 4 plus 4. What if I wanted to find f of negative 5? That would be the square root of negative 5 plus 4, which is the square root of negative 1, which is not real. So right over here at negative 5, I don't get a real answer. It's not in the domain. The domain starts at -4. You seeing that?
That makes sense.
That's good. All right. We are out of time and I've got a next meeting starting pretty quick. So I am going to stop the recording.